Good afternoon, everybody. My name is Prerna and I represent the enterprise team of Cognixia. On behalf of the team here, I welcome all the attendees today for the workshop of IoT basics. I'll go a quick minute about talking about Cognixia. So Cognixia is a leading digital talent transformation organization and we cater to over 450 plus clients all over the globe. We also have a trainer pool of over 7,000 trainers, SMEs, industry veterans, and consultants included. Our forte lies into training corporates and IT professionals on various digital and IT technologies or the emerging technologies as we rightly term them. We support our clientele on various modes of training that includes live virtual sessions, just something equally and similar to what we'll be having today, as well as the classroom setups as well. Quick introduction about our speaker today. Mr. Shafi Patel is a part of the Cognixia family and carries over 20 years of experience, extensive experience on IoT, along with lot many other technologies. He's an SME for us for this particular topic and has been delivering to our prominent clients across the globe. I'm sure some of you would have been trained by him already in your respective organizations. I'm looking forward to this workshop, which is definitely going to be very engaging. So I'm sure and hopeful all of you are ready to make your notes and shoot out your questions whenever needed. Please do not hesitate in clearing out your doubts. Also, you can write back to us towards the end of the session. So, Shafi, you can actually take from here and I'll see you by the end of the overall session. Thank you.
Thank you, Prerna, and thank you, Sachin. Okay, so let's get started. On behalf of Cognixia, I welcome all of you to this beginner level workshop on one of the most fascinating technology of today's era, Internet of Things. As this session is completely oriented towards hands-on exercises, hands-on practice, building, architecting, and deploying your code on devices, on gateways, on cloud platforms. So we'll have a series of exercises and demonstrations. During session, as I can see, there are hundreds of participants and people are still logging in. So I don't know how much interactive this session would be depending on number of participants, but I'll try my best to answer as many questions as I can. And I'll keep this entire session as interesting and engaging as possible. Anyways, we all know that all those technologies we have been talking about for years, technologies like big data, data analytics, IoT, these technologies promised a transformation of our world. And good thing is, as promised, these technologies have been transforming our world. Most of time people use a word disruption, but in my opinion, we should call it, or we should call this group of technologies enablers, because they have been enabling system builders like us to address more and more real life problems. IoT is an umbrella technology. It's an interdisciplinary area. And whenever a discussion on IoT takes place, it encompasses all other technologies. Being an ensemble of all other technologies which have been invented so far, IoT has all those technologies is its subdomains. So microcontrollers, sensors, communication technologies, internet, cloud platforms, big data tools, and machine learning and AI. All these technical domains or areas are subdomains of IoT. In this training program or workshop, I will introduce you to all those best practices, beginning from how to build your system and ending with how to ensure its security as well as privacy of applications and data lying on your devices, moving on your networks, and residing on your cloud platforms for long-term analysis. So let us begin with a basic definition of IoT. What does IoT mean? So those who are new to this concept, and most of times those who have been working in this area for years, most of times this term is being, this is the reason I want to bring all of you on the same page. IoT is all known as a technology used by this Kevin Eston in 1999. The idea was to extend 4 types of capabilities to mundane objects. Here, mundane objects refers to all the things, all those things that we use in our day-to-day life, from your wristwatch to your car to your shoe to your washing machine. These are all mundane objects. And once you extend these 4 capabilities, sensing, computing, communication, and actuation, to mundane objects. Sensing means sensing the real environment, real life environments, and collecting data from there. Computing enables performing arithmetic and logical operations on the collected data. Communication means sharing raw data as well as information extracted from data. And actuation means converting final decisions into physical action. These are the 4 types of capabilities once embedded into a mundane object, transform it into an IoT system. This system could be, one device working in a silo, or this systems could be extended to be a system of systems deployed in a distributed manner in the form of a network, and this network could be as big as a global network. So IoT doesn't mean you connect your devices to internet. IoT means you connect your devices to each other, and if necessary, if you want to have globally connected network of devices, then it's rather than building your own network, you can rely on a ubiquitous economical global network called internet. Okay. So as anticipated by 2020, it was anticipated that there would be 50 billion devices. And now there is a new figure that by 2030, we will have 300 billion devices connected to internet. Okay, so this number is growing day by day. Now, as I just alluded, IoT could be extended and could take shape of a global network and could even become a system of several subsystems. So let us look at this components of a global IoT solution. See, an IoT solution, or you can also call it IoT ecosystem, you find devices. These devices are equipped with sensors to acquire data, network to communicate data, cloud platforms to store and process data generated by the sensors, analytics to derive insights from the sensor data and generate reports and dashboards. End user applications means the traditional technologies like HTML, Android devices, or you can have cloud-based end user applications. And third-party integration tools means to allow seamless integration with existing systems. And most of the systems are enterprise IT solutions like ERP solutions or CRM solutions. So you can have your IoT systems integrated with this existing enterprise IT systems. Now, one of the challenge being faced in this area, also called OT to IT integration. Anyway, the discussion on this is out of scope of today's workshop, but just to give you an idea that integration with existing IT solutions is one of the challenge being faced by IoT solution builders. So let us look at how the systems or subsystems or components are connected to each other, and what do applications do once applications are deployed on them. See, IoT is all about data. The first step, and this is the responsibility of IoT nodes. So there are going to be 2 types of IoT nodes. IoT nodes, those who acquire data, we call them sensor nodes, and IoT nodes, which are responsible for commands execution, are called control nodes. So there are 2 types of IoT nodes, and they both sit at 2 ends of our IoT network. This is why we also call them endpoint. So what do they do? See, IoT nodes are responsible for data collection. The next step, the process of combining this data collected by IoT nodes with data coming from other sources is called aggregation. Then in the third step comes storage. In the next step comes data analytics. Then comes decision making. And finally, these decisions are routed back to IoT nodes who are responsible for execution of commands to generate physical action to manipulate real life environment in a corrective manner. So this is the end-to-end flow of data across the system, and we can call it end-to-end computational loop. See, one of the strategic decision that IoT builders need to make is where to close this loop. And I quickly introduce you to three computing paradigms based on this strategies. So the first point where you can have this loop closed is on your device itself. You can collect data, you can aggregate data, you can store, you can analyze, you can make a decision, and finally you can execute the commands here itself. This computing paradigm is called embedded computing. We call it embedded computing. Now let's say if the decision making process has dependency on data coming from other systems, but this systems are local systems within the network. In that case, you can have your data aggregated, stored, analyzed, and decisions could be made on a local server or local device or local computer called gateway. This local infrastructure is called edge infrastructure, and this computing paradigm is called edge computing. In the next step, you can have, let's say, if your decision making processes have dependencies on global data sources, for example, data coming from social networking site, Facebook, Instagram, or a manufacturer's website. So let's say if this all of this global data points could be collected on a cloud platform, and data generated by your devices could also be collected and aggregated and finally analyzed on cloud platform, and the decisions could be routed back to IoT nodes responsible for command execution. And this third computing paradigm is called cloud computing. Okay, so we are going to explore all these three options in today's workshop. I'm going to show you how to build IoT devices, collecting data for you. Second thing, how to have this data collected on a gateway. And third thing, how to have this data forwarded to a cloud platform. Okay, since this is a beginner level workshop, we will not have any analytics, analytics related exercises or machine learning and AI related exercises. Okay, I will focus more on data collection, collecting data on local devices, on gateways, and on cloud platforms. Okay, so let us go for a practical demonstration of what we just discussed. Okay, so next thing is, and I'll get back to this, after a basic demonstration. I just want to show you all those components, especially the computers or development boards, which are used by IoT professionals across the globe to not only build POC projects but also commercial projects. So an IoT node, as I just explained, an IoT node means a mundane object with sensing, computing, actuation, and communication. There's four capabilities embedded into it. Now, when it comes to selection of these components, you will have to take several parameters into consideration. And these key parameters are reliability, resiliency, interoperability, security, and privacy. I'm not going into details of these key parameters because this workshop is a workshop where we want to provide you practical understanding of everything. So to build a technology infrastructure, as I just alluded, is a combination of all those components. And first component is IoT node or IoT device. So how to build an IoT device. And to provide you a practical understanding of all those components, I'm going to share my webcam with all of you. I have all those computing boards here on my desk. Let me plug my cam and introduce all those computing boards to all of you. So I have a good collection of development boards, communication modules, and sensors on my desk. Let me introduce all of you to this first. I'm starting with the one of the most popular and an open source prototyping platform called Arduino. So the board which is in my hand, we call it Arduino Mega board. Now those who have used Arduino boards or Arduino technology, they should be familiar with this board. So Arduino Mega is one of the development board, and this family of boards has several members. Okay, I have this one is Arduino Mega, and here we have a small size development board or microcontroller based development board. You can call it. This chip here is a single chip computer. This is Arduino Mini. Okay, so we have Arduino Mini, Arduino Mega. There is Arduino, one more popular board in this family called Arduino Uno. But anyway, Uno is not here in my collection. This is the second most popular development board called Node MCU. Node MCU is based on ESP12E SoC from Express If. This SoC belongs to ESP8266 family of SoCs, which comes with on-board or on-chip Wi-Fi and on-chip TCP/IP protocol stack. So this is one of the development board. Now, this two development board and the third development board, which is also equally popular, but it's not a microcontroller board. This is a single board computer called Raspberry Pi. Now, there are thousands or even millions of Raspberry Pi users across the globe, and Raspberry Pi is one of the most popular single board computer used for IoT prototyping. Okay, it's a 1.2 gigahertz computer. In my hand, Raspberry Pi 4, which has been recently launched, is a 1.5 gigahertz computer. Okay, so Raspberry Pi, Arduino, and Node MCU. These are the three development boards which are supplied by us to all the IoT learners when they join our IoT training program. We offer multiple training programs on IoT. These training programs are beginner level, intermediate, and advanced level training programs. And in all those training programs, we cover all these development boards. Now, I'm introducing you to one of the development boards from Intel. This is Intel Galileo. This is Arduino compatible board. As you can see here, this pin out here, pin out is just like Arduino Uno, and rest of the board is based on x86 architecture. So this is Arduino Galileo Intel's Galileo board, Arduino compatible board from Intel. I have a $9 computer in my hand. This computer is called chip, CHIP, chip. It costs $9 and it's a 1 gigahertz computer. So this is also a single board computer, just like Raspberry Pi. Then I have a starter kit from Microsoft. This can be connected to Microsoft Azure. So those who are interested in learning how to build devices and connecting them to Microsoft Azure platform, they can use this Microsoft Starter Kit. It comes with a small size display here, as you can see, and it can be programmed using Visual Studio. Then I have a high-end computer from TI, Texas Instrument. This is TI Launchpad board. Launchpad is a series of development boards from TI IoT ready boards with on-chip Bluetooth sub 1 gigahertz and Wi-Fi connectivity. The specialty of this series of SoCs, the microcontroller plays here, where my thumb is pointing to. This is a secure platform, highly secure platform. It comes with several on-chip security features starting from secure file system to secure boot to network security and hard-coded device ID. Plus, this also comes with on-chip cryptographic accelerators. Now, what is cryptography? I'm going to share a practical example of that and where do we use cryptography as a science when it comes to IoT. I have a series of communication modules here. For example, I have LoRa modules. I have Semtech modules. I have a GPS receiver. This GPS receiver can grab coordinates for you from satellites. So you can tag your data. You can add location tag with your data. You can uh, uh, add timing information with your data. You can add current date with your data, and you can collect all this in real time, from geostationary satellites using this GPS receiver. It can be interfaced with these development boards, and you can build IoT use cases like vehicle tracking systems. In my next workshop, advanced level workshop or intermediate level workshop, which is going to be organized on 8th of April, I'll cover a use case based on GPS receiver. Then here I have Zigbee modules. These are Zigbee modules. Zigbee is one of the prominent technology. This is being used to build home automation, factory automation, and smart city use cases. Then here I have a Wi-Fi module, ESP01. This can be used as add-on module to enable a legacy microcontroller like Arduino Mega to be connected to internet. And here I have a Bluetooth module. And then I have bunch of sensors here, starting from, a simple light sensor to this is a light sensor. This is a flex sensor. We call it a flex sensor that can catch movements, to motion detectors. So this is a motion detector. And here I have a sensor which can capture temperature and humidity for you. A very popular sensor called DHT22. Here I have a sensor which is accelerometer. Accelerometer is used in devices like fitness tracker, where you can count number of steps. And then here I have a very simple IR based proximity sensor. And the last sensor, I would like to introduce you to a tiny temperature sensor called LM35. Okay, so these are all sensors that I have with me. And here I have a sensor tag from TI. This is a box, which contains several sensors, and this is a smart box. Let me take it out from its packing. As you can see here, this is a smart microcontroller based box, and it has several sensors mounted on it. It comes in this package. This is a high-end sensor module from TI, Texas Instruments, and it is called Sensor Tag. So this is the collection, and this should be your hobby, or this should be your passion. When it comes to IoT, you should know how to deal with this type of development boards and communication modules and sensors, and how to have all of them connected to build an IoT device. Okay, so now what do I have here? As you can see, I have a node MC board placed on a breadboard. A breadboard is a board which is used by electronic system designers to place the components and connect them to each other. So what do I have here? I have a node MCU development board placed on my breadboard, and I have the LM35 temperature sensor connected to it. Now what I'm going to do over here, I'm going to program it. Let me make some room here. I'm going to program this board to capture current temperature, current environmental temperature, and then we'll have this temperature not only displayed on our screen, but we'll also have this temperature communicated to a board which is here on my table, Raspberry Pi. Okay, so we'll be using Raspberry Pi is a gateway. Okay, so let me show you how to program this board. Okay, so to program this board, we use an IDE called Arduino. You can have this IDE downloaded from arduino.cc. The website is arduino.cc. Okay, I'm taking you to that website first. Those who are new, Those who are experienced, they already know from where to download this IDE and how to use it, how to program it using Arduino programming language. Those who are new, they can go to this website arduino.cc and they download this tool, this IDE from downloads section. Okay, so this is the website and this is the tool we are using to program this board, Node MCU board based on ESP12E chip. Now what I'm going to do here, I already have downloaded and install this IDE over here, and I'm using a programming language. As you can see, this is a high level programming language, and I'm using this programming language and I've written this program. Let me walk you through this program. What I'm doing over here, I'm using an analog pin of Node MCU board. Let me put a comment for you here. Analog pin of Node MCU board to read the signal, output signal coming from sensor's out pin. A sensor, this LM35 central pin, center pin means middle pin. It has three pins. Middle pin is connected to A0 pin here with the help of this wire. So I'm reading this voltage coming from sensor. Then in the next step, I have declared two variables, temp-c and S voltage. Temp-c is to hold final value. The final value which is going to be calculated based on the sensor voltage coming from sensor, and this is an intermediate variable S voltage. I'm going to communicate this temperature value at a data transmission rate defined here 9600, and the protocol which is going to be used is going to be UART plus USB, because the board, as you can see here, Node MC board, it supports a data communication protocol called UART, and I've connected it to my laptop using a USB cable, this white color USB cable. Okay, so this is why I'm calling it UART plus USB, because a UART to USB converter is already mounted on Node MCU board. Now, in the next step, once we have initialized the communication inside setup, in the loop, I'm reading the data, analog data from the sensor, and then using a formula to convert. This formula is based on characteristics or technical specification of on-chip ADC and scale factor of temperature sensor. The sensor which is being used by us has a conversion factor 10 millivolt per degree Celsius. Okay, so that means 1 degree Celsius change will generate 10 millivolt shift in the output of sensor's voltage. So these formulas are giving us the final value temperature degree Celsius, and I'm printing this final value temperature in degree Celsius on my screen. Now let me upload this program, because this program is going to reside on my Node MCU board. So I will have to, from my computer, from my laptop, I will have to upload this program and let this program be hosted, be residing on Node MCU board. So what I'm going to do now, I'm selecting the board from the boards manager. I'm selecting Node MCU 1.0 board, and then I'm selecting the COM port, the port which has been assigned to Node MCU once it is connected to laptop. So COM4 is my communication port, and post this, I'm clicking on this button to compile and upload the program. Uploading may take some time, and as you can see here on my webcam, you'll see this LED on Node MC board will start flashing. Okay, so as you can see here, the LED on Node MC board is flashing. This flashing means the program is getting uploaded, and you can also see here in on my laptop screen the percentage of or the progress of program getting uploaded on Node MCU board. Okay, so once program has been transferred, then it's not necessary to have your board connected to your laptop. You can even take this micro USB cable out from your laptop, and you can power up your entire sensor plus Node MCU board. This has become a sensor node. It can collect data from anywhere. So you can place it in your garden, or you can place it in your kitchen, or you can place it in your living room. connected to a wall outlet with the help of your mobile phone adapter. So you just need a 5 volt power supply, and that 5 volt is converted into 3.3 volt to run this microcontroller board. Or you can even run this on a 3.7 volt battery. Okay, so this has now become a sensor node. It has sensor, it has a computer, and it has on-chip Wi-Fi communication capability. Okay, see, in the first step, we have just uploaded the program and we are capturing data. Okay, so this is the temperature value that has been captured by node MCU board with the help of LM35 temperature sensor 31.52. Okay, so this is my room temperature, the temperature where this sensor node is placed. Okay, so this is the first step. We have built a sensor node. Now what is the next step? The next step should be to connect this sensor node either to internet and over the internet to a cloud platform, or connect this sensor node to a local computer first, and then connect this local computer to internet and over the internet to cloud platform. See, the first step is a simple. You can have this sensor node connected to a cloud platform directly, but this is not recommended. You know why? Because internet is an open network, and as I just alluded, security and privacy are the topmost concerns of technology users. And when it comes to confidential data, you need to ensure this that your data is communicated in a secure manner. Your data is stored on your computer in a secure manner. Your data is stored on the cloud platform in a secure manner, and privacy of data is guaranteed, means data is only and only available to its owners. Okay, so a computer like node MCU, it's a tiny computer with limited resources. You cannot have a large size antivirus solution or a firewall running on it. Okay, so instead of deploying complex security solutions on your IoT devices, let's say currently we just have one sensor node with us. Think about an IoT use case like a smart city use case. In a smart city, you may have thousands of sensor nodes or millions of sensor nodes or billions of sensor nodes. Connecting all of these devices directly to internet means allowing you know hackers or adversaries, or bad guys, allowing them to break into your networks, because the more entry point you have, the more exposure point you have in your network, the more possibility of breaking into your network would have, right? So this is the point here. It's not recommended to have our low power resource constrained sensor nodes or control nodes directly connected to internet. So what is solution then? The solution is we can use a gateway, and as a gateway I am going to use you know one of the development board which I just showed to you. And which one is that? This is Raspberry Pi. Okay, we are going to use Raspberry Pi to keep our sensor node secure from external world. Okay, now first thing that most of times, the first difficulty that new users face, and as this is a beginner level workshop, so I'm just going to give you an idea, once you have your Raspberry Pi with you, how to set it up. you know so to set up the Raspberry Pi, you will have to download an operating system. See, Raspberry Pi is a single board computer. It supports several operating systems, and you can find a list of supported operating systems, as well as you can download this operating systems from this website, raspberrypi.org. Okay, so here if you go to download section of raspberrypi.org, you will have all these supported operating systems available to you. So Raspbian is an optimized distribution of Linux, and Linux, as we all know, is a very stable, user-friendly, and secure operating system. And there are several distributions of Linux. The one here we have is called Raspbian. Okay, so you can download Raspberry Pi OS for your Raspberry Pi from here. There are other operating systems supported by Raspberry Pi like Ubuntu Mint, Ubuntu Core, Ubuntu Server, even Windows IoT Core. These are all operating systems supported by Raspberry Pi. If you click on Raspbian, you will have a choice to either download Raspbian Buster with desktop and recommended software. All the software comes preloaded, or you can go for a simpler version of Raspberry Pi or Raspbian, I mean say. You can download it from here. I would recommend Raspbian Buster with desktop and recommended software. How to download? By clicking here on download zip file. But because this is a large size file, so ensure that you are on a high speed network while you are downloading this OS operating system should be on a high speed network. Now, once you download this zip file and you unzip it, what you are going to get is, let me show you. After unzipping, you're going to get a .img file. This .img file is called Raspbian Buster Full. So I downloaded, I unzipped, and as you can see here, the size of the file is 6.82 GB, 6.82 gigabyte. Okay, this is your operating system. This is OS file. Now this OS file, you will have to have this OS file uploaded on a SD card. Let me show you. See, if you look at my webcam, you should have a SD card, minimum 16 GB size SD card with you. Okay, 8 GB would also do, but it's good to have a 16 GB card. So a 16 GB SD card, and then you should have a SD card adapter. Once you put SD card in the SD card adapter, you will have to plug this SD card into a SD card slot available on your laptop. In case if there is no SD card slot available on your laptop, what you can do, you can use a USB SD card adapter. Okay. In the next step, you will have to, once your card has been detected as a drive, I'm on a Windows PC, so obviously I will have to open my computer to find out the drive later assigned to my SD card folder. Okay, so what do I have here? The drive later assigned to is F, and since I already have a partition created there, boot, this is also being displayed here. So once you have your drive later displayed here, what you can do, you can right click on your drive later and then you can click on format. Okay. Recommended file type is FAT32. Select FAT32 or go with the default settings and select quick format to quickly finish this process. Once your card has been formatted, okay, then in the next step, you can use a software called Etcher. Etcher is a utility that you can use to upload this image file, the image that you just downloaded. You can have this image file uploaded on your SD card using this utility called Etcher. Okay, once your image file has been uploaded, what you can do, let me show you. I have this image file ready here. Okay, good. Etcher is this software, this is interface. So let me show you how to select image. Okay, so I'm selecting my image, Raspbian Buster. Once the image is selected, you can select your drive later from here. By default, it selects your F drive or whichever is the later assigned to your SD card drive. And then you can click on flash. Flashing takes approximately 10 to 15 minutes. So this is why what I did, I have already flashed, I already uploaded that IMG file on my SD card. Okay. Now in the next step, one of the problem most of the time people face is how to connect. Now once you have your SD card ready, once you have your image file, so this is all the OS files that which are present on our SD card. Now, next problem people face is how to configure Raspberry Pi, how to connect it to your Wi-Fi network. And most of time to connect it to your Wi-Fi network, you need a separate set of keyboard, mouse, and monitor. But anyway, there is a tricky way of setting up your Raspberry Pi without using these things. And what is that? Let me show you how to do it. See, first thing is you will have to create a SSH file. You know, so as you can see here, I just right-clicked. I'm going to new, and then I'm going to create a new text file. Okay, a new text document. I'm not putting anything inside this. I'm just assigning it a name SSH. That's it. Okay. Now, why am I doing this? See, this at first boot, this file will be used by Raspberry Pi. Once this operating system finds this file in the root folder, it's going to enable SSH. SSH is an interface we call it secure shell. You can connect to your Raspberry Pi, you can interact with your Raspberry Pi using SSH. Okay. And then what I'm going to do, I'm going to put one more file. This file is a configuration file. The name of the file is WPA underscore supplicant. Okay, and let me open this file and show you what is there inside it. See, what I have put inside it is my SSID, my password, and the key management protocol, WPA, Wi-Fi security. The country code here is 356. This I'll share a link from where you can find country code. So this country code 356 is for India. For other countries, there are going to be different country codes. So what I've done, with this content, I have created this file. File is named as WPA underscore supplicant. And then I'm going to put this file, should have a .conf extension. I'm putting this file on my SD card. Okay, so in the SD card, boot folder, the root folder where I have other files, I'm going to put this file. Okay, so now I have both SSH and WPA supplicant, both the files uploaded on my SD card. Okay, I will take my SD card out from my computer. Okay, as you can see on my webcam, and now I'm going to insert this SD card into Raspberry Pi's SD card slot. And where is that SD card slot? At the back plane, you have Raspberry Pi's SD card slot. Okay, so now we have loaded OS. This is Raspberry Pi's hard disk, you can say. Okay, this has operating system loaded in it. And in the next step, I'm going to power up my Raspberry Pi. So I'm going to use uh, an adapter to power up my Raspberry Pi. Let me show you how to do it. So I'm using a 2 ampere adapter. See, it is recommended to use a powerful adapter because Raspberry Pi has Wi-Fi and Bluetooth communication interfaces. You know, initially when it comes to connecting Raspberry Pi to your Wi-Fi, it draws heavy current. So always use a separate adapter to power up your Raspberry Pi. So as you can see here, I have powered up my Raspberry Pi. The power LED is glowing continuously. The green color LED is for displaying CPU activity. Okay, so nothing is connected to Raspberry Pi, no keyboard, no mouse, nothing. Okay, now in the next step, what I can do, I can use a utility called Advanced IP Scanner. Okay, and I know that my network is a class C network. Class C network means a private network. In a private network, you usually find IP addresses starting from 192.168.0 onwards. So first three octets are 192.168.0, and then you can have 255 hosts. So starting from 0 to 255, you can have this many hosts, or it should be 254, right? uh, what I'm doing here, I'm scanning my network to check or to list all those devices which are connected to my network. And because I put this Wi-Fi configuration file on my Raspberry Pi, should connect to my Wi-Fi network on first boot. Okay, so let's wait scanner to find and list Raspberry Pis. Okay, so as you can see here, I have two Raspberry Pis listed here. One, and there are grayish Raspberry Pis. You know, these are offline nodes. I have one with 105 and second one with 106. Any 104 or 106. I will have to find out. Now, question is how to find this out. See, I already have one more Raspberry Pi, and I'm connected to it using VNC. Okay, so this is 105. This is my Raspberry Pi, which was already there. So, but anyway, I will have to SSH and then find out, okay, which one is a Raspberry Pi out of this many, you know. So let us do this using a command, a terminal command. I open my terminal command and I'm running a command SSH pi at the rate. Okay, the first Raspberry Pi is 192.168.0.104. Okay, so I'm sending a SSH request to this Raspberry Pi. Okay, it says host key verification failed. No props. Let's start with 106. Okay, now this says, are you sure you want to continue connecting? ECDSA. Now, how many I don't know how many of you are familiar with this term, ECDSA. DSA is a cryptographic algorithm, and EC is one of the variation of that, elliptic curve. Okay, so it is giving me a fingerprint, means that is being used for security. So I'm saying yes, and I'm connected to node. It's asking for password. Default Raspberry Pi password is Raspberry. So I'm connecting to it, and I'm in. Now see, first thing I'm going to check is my present working directory. So it says I'm inside home/pi. Okay. Next thing I'm going to check is ls. Ls means list all the available files. But as you can see here, this Raspberry Pi has got this many files in its folder. It means this is my older Raspberry Pi. Okay, this is the Raspberry Pi I am already, uh, which was you can say the Raspberry Pi, my personal Raspberry Pi. So what I'm going to do, I'm going to open one more terminal window, and I'm going to SSH into the Raspberry Pi, which has been listed here at the end. Okay, so SSH pi at the rate 192.168.0.105. Let's see. Okay, so okay, just hold on, guys. I think I will have to go to my. So these are all the problems that you face while working with this type of tools. So saying there is a entry in my SSH folder, and the entry is not matching with the known host. So it's an IP address which is being reused, and there is an entry in my see, there is an entry in my known host file. So let me delete both the entries. I'm just deleting both the entries, because the key which is being received from my new Raspberry Pi was not matching with this. So now I think it should work. Okay, so as you can see here now, it's working. Okay, and I'm in. Okay, let us check present working directory. Present working directory is home/pi. Let us check content of this working directory. And good thing is we do not have anything inside it, right? This is this is my new Raspberry Pi. Now we know what is the IP address of this new Raspberry Pi. We know IP address, right? We can find out IP address once again by running this command. Now we are into that Raspberry Pi. See, SSH means I have logged into this Raspberry Pi. It's a Linux system, so if config command should give me all the IP addresses, should show me all the IP addresses. And here we have WLAN 0, 192.168.0.104. This is my new Raspberry Pi's IP address. Good. So this is how you can have your Raspberry Pi connected to your Wi-Fi network without using any keyboard, mouse, monitor. I hope you like this idea. And in the next step, I'm going to enable an interface on this Raspberry Pi. I'm running a command sudo. Sudo means super user. I'm running this command as a super user. Let me clear the screen first so that it is clearly visible to all of you. Oh, I will have to reconnect. No, it's there. Okay, good. So I'm running command sudo sudo. See, sudo means I'm running the command as a super user. Okay, I'm running the command as super user, and then I'm going to run command this command sudo raspi hyphen config. The command is sudo space raspi hyphen config, and it has provided me Raspberry Pi configuration tool. And what I can do from here, I can go to interfacing options, and in the interfacing options, I can enable VNC. Okay, now what is VNC? VNC is a graphical remote access to your Pi using real VNC. Real VNC is the utility that you can download. The client can be downloaded on your laptop. Raspberry Pi comes with a pre-installed, or Raspbian OS comes with a pre-installed VNC server, but by default it is disabled. How to enable it? This is the method I am sharing with you. So once you have logged into uh, Raspberry Pi, Raspbian OS using SSH, then you can open this Raspberry Pi software configuration tool, select VNC. Once this is done, you use your arrow key to go to VNC, hit enter. Okay, it asks you, would you like the VNC server to be enabled? Once again, use arrow keys to select yes, click on yes, and it says, good news, VNC server is enabled. Okay, so now what I can do, once again, I'll be using my arrow keys to come out of this finish. Now, you don't need SSH anymore. Okay, I can close SSH window. But there is one more tool that you can use, and this tool is called bitwise SSH. How to use bitwise SSH? I'm going to show you that shortly. Bitwise SSH also allows you to have files copied from your laptop to desktop, and using just drag and drop facility. What I'm going to do now, I'm going to use VNC viewer. This is VNC viewer, and now I know my Raspberry Pi's IP address is 104. Okay, so I'm going to put this IP address here, 192.168.0.104. Okay, so it's already here in the list. Okay, now it says VNC server identity check failed. Okay, because I already this IP address was used by another host on my network. So anyway, click on continue, and once again it's asking for username. Default username for Raspberry Pi is Pi, and default password is Raspberry. Okay, click on OK, and we are connected to our Raspberry Pi, new Raspberry Pi. See, it says SSH is enabled and the default password for the Pi user has not been changed. See, these are what you can call vulnerabilities. Vulnerability means a weakness of your system, and default username password is most commonly found vulnerabilities in IoT devices. You know, there was a security incident in October 2016. Millions of IoT devices were hacked, and these IoT devices were used as launchpad to attack domain name servers globally. And this attack, also called DDoS attack, distributed denial of service attack, this brought down hundreds of web servers across the globe. And you can read more about this DDoS attack, distributed denial of service attack of October 2016. So this incident revealed that IoT devices could become a low-hanging fruit for hackers. And one of the most commonly found vulnerability is obviously default username and password, right? So the first thing you should do is change this username and password. I'm going to share, uh, that link with you how to do it. But anyway, because we have this workshop is short duration workshop, so I'm quickly taking you through this. So I'm selecting my country. Uh, it's not Windows system, so we'll have to be a bit patient, right? So India, and then language, obviously English, and then time zone, let it be Kolkata, and do not forget to select use US keyboard. The next step, click on next. Okay, so it's setting up your system. Now, while your system is being set up, what you can do, you can minimize this. You can right click on your screen. You can go to the desktop preferences. You can go to defaults, and you can click on small screens. Okay, so that on your laptop, the screen fits suitably. Okay, so now I have everything here. My VNC server is enabled. Okay, the welcome. Okay, it's asking for password. You should change this password. Okay, I'm not doing it right now, but I would suggest you to do this. Okay, it's searching for network. Let's skip this. It's asking for updating OS. Let's skip this because it's time-consuming process. It's asking for restarting the Raspberry Pi. We can restart. Okay, let it restart. Okay, so as you can see here, I have done uh, all those steps to configure and set up my Raspberry Pi. Now, see, I'm sharing a link to one of the article posted by me where you can get this entire thing, the entire process that I explained to you. uh, I'm sharing this link in the chat window. I don't know whether chat is going to be accessible to you or not, but anyway, uh, you can click on this and to gain access to this article that I have posted here. All the steps have been documented and are available how to set up your Raspberry Pi headless without using keyboard, mouse, and monitor. Okay, now once you have your Raspberry Pi set up, what next? See, where were we? We wanted to connect our sensor node to this Raspberry Pi. Okay, we wanted to connect. See, it has been rebooted, so I'm getting connected to it once again. Okay, so I'm connected to my new Raspberry Pi. Now, what do I need here? See, I need here a server, a server that can ingest data for me. Okay, that can take data for me. Now, when it comes to setting up communication amongst or communication between two devices, two machines, this you always find this term being used everywhere: M2M communication, machine-to-machine communication. Machine-to-machine communication means two IoT systems which are subsystem of a larger solution connected and communicating with each other. So the first step is obviously connectivity. The second step is communication. So connectivity means here the connectivity technology being used by us is Wi-Fi. So Wi-Fi can allow my node MCU microcontroller board, which is acting as sensor node, to connect to Raspberry Pi. My Raspberry Pi is already connected to my Wi-Fi network. Okay. So once I connect my node MCU to my Wi-Fi network, and once they both are on the same Wi-Fi network, we can set up communication. We can program them to communicate with each other. Okay, so this is exactly what we are going to do now. Okay, but what do we need on this Wi-Fi, Raspberry Pi? So we need a server, either a HTTP server ingesting data coming from Node MCU, or responding to requests coming from Node MCU, or a MQTT broker. MQTT is one of the most suitable lightweight protocol for IoT devices. This is used by IoT devices. You can call it a language of IoT applications. IoT applications can use MQTT protocol. MQTT stands for Message Queuing Telemetry Transport. MQTT has several versions. The versions which are in use are 3.1 and 3.1.1. The recent version of MQTT is version 5. And MQTT, either you can go through the entire documentation of MQTT. This is the official website, mqtt.org. You can docs, and there you can find documentation of MQTT protocol in the form of a single page HTML or PDF. Or in a simpler way, you can use MQTT libraries. Okay, so I'm going to share two examples of MQTT libraries. The first example is PAHO MQTT library. PAHO is Eclipse project, and PAHO library, not just one library. PAHO project has several libraries, and these libraries are written for M2M communication, MQTT as well as MQTT SN, which is stand for MQTT Sensor Network. You can download these libraries to build your applications. From this page, you have libraries available in almost all the languages. So whether you are building an Android application, or you're building a Python application, or whatever you are doing, you have all those libraries available to you. But MQTT version 5 library is only available in C. So because of this reason, 3.1 and 3.11 are still in use. Okay. So I'm going to share two examples of these libraries. One is Python library. See, on Raspberry Pi, we are going to use Python to develop our application to ingest data coming from Node MCU. And on Raspberry Pi, I can install this library using this command, pip install paho-mqt. So how to have this installed on Raspberry Pi? Let me show you. We have our Raspberry Pi here. I'm going to use a terminal window. I'm opening a terminal window, and in this terminal window, I'm going to use command sudo pip3. Why pip3? Because this Raspberry Pi has Python 3 installed on it. Okay, so for Python 3, I'm going to use to download and install paho-mqtt library. Now see, pip is Python package manager. Pip is used for installation, uninstallation, and management of packages or libraries on a computer with a Python environment. Good thing is Raspberry Pi already has Python installed on it. Raspberry Pi already has pip utility installed on it. So we are using the pip utility to download and install this library. And as you can see here, once the library has been installed, I can have Python applications based on this library running on it. So it's a quick process. We have downloaded and installed 1.5.0 version of PAHO MQTT. So this is a simple process. MQTT is a much simpler and lightweight protocol compared to HTTP. This is why we prefer it for IoT communication. See, to dive deeper into this discussions, for example, why not client server architecture? Why pub server architecture? Because MQTT, we are going to use MQTT to uh, implement pub sub architecture. Pub sub is a short form of publish subscribe architecture. This is a newer architecture compared to client server architecture. See, in our regular training programs, IoT training programs, we cover all these topics in depth. So you get a practical understanding of, how to select development boards, how to select sensors, how to select connectivity layer technologies like Bluetooth or Wi-Fi or sub 1 gigahertz or LoRa or Sigfox or 802.15.4, and then you get a practical understanding of selection of your architecture, client server or publish subscribe, and you also get a practical understanding of selection of application layer protocol, whether to go for HTTP or MQTT. Okay, now see, once MQTT has been installed, I can have my Python application running over here, ingesting data coming from my sensor node. And for this, what do we need? We need one more application. This library is just for developing client application. But before that, let me show one more example of a library we are going to use on our Node MCU. So on Node MCU, we are going to use an Arduino PubSub client library. The library I'm going to use is called PubSub client library, and here is the library page. So I'll be using this library to build an application which is going to run on my Node MCU sensor node, and I'm going to use this library PAHO MQTT to build a Python application running on my Raspberry Pi, taking data from me and then uploading this data on a cloud platform. Now question is, which cloud platform? Okay, so there are two cloud platforms we can explore. AWS, Amazon Web Services, is world's leading cloud platform, and AWS has all those services called IoT group of services. Okay, we can use these services to build our IoT solution. And the front end service on AWS is called AWS IoT Core. So either I can use AWS IoT Core or I can for Azure, Microsoft.com. And here the front end service which allows our devices to connect and upload data or be controlled from cloud. The front end service is called IoT Hub. Okay, so I'm going to show you how to have your Raspberry Pi connected to AWS Cloud Platform. But before that, what do we need on Raspberry Pi? We need a broker. A broker is just like a HTTP server, and the broker I'm going to use on my Raspberry Pi is Mosquito. Okay, so we have a broker called Mosquito. It's open source broker. You can download and install this broker on your laptop or on your Raspberry Pi. Okay, and from where to do it? From here. Okay, so I'm not getting into details because installation is a time consuming process. So I already have Mosquito broker and Python application created on my older Raspberry Pi. Okay, so let me connect to my older Raspberry Pi, which is now 107, I think so. Or if 107, then 106. Yes. Okay, so I have two Raspberry Pis. Okay, this Raspberry Pi already has a Mosquito broker. Let me show you. So Mosquito is a server, and I'm just going to show you that Mosquito is installed and it's already running here on port number 1883. Okay, port number 1883. Now let me just show you how does it work? How does MQTT communication take place? See, MQTT is a very simple protocol. I'm going to use two client processes here, and I'm going to show you, how messages are exchanged. So I'm creating a client here, a client process called subscriber. Okay, using a command mosquito underscore sub hyphen t. It is subscribing to a topic called test topic. Okay, it is subscribing to a test topic, and now there is a second client which is going to connect. Okay, so there is a second client. This second client is going to connect to broker as a publisher. Okay, and this is going to drop a message on this topic, which is going to be forwarded to the client waiting for it. Okay, so I'm dropping a message hello from here. Okay, and as you can see, the message has been delivered from this message has been delivered to this client. Okay, so MQTT is such a simpler protocol that it can even be used for inter-process communication. Okay, now what I'm going to do, I'm going to use a program on my Node MCU, and here I'm sharing a second program with you. In this program, I'm going to send these messages, a JSON message from my Node MCU. Okay, so as you can see here, the temperature that we just captured, temp-C, and I printed this on serial monitor. So I just showed you the program up to this point. Okay, up to this point. What I'm doing over here in the next step, I am converting this temperature data into a temperature string. Okay, into a temperature string with the help of a function called d2strf, temperature string, and then I'm publishing from here. Okay, so now we have our node MCU acting, which is going to act as a publisher. It is going to publish actual temperature values on temperature topic. Okay, see, if you look at the beginning of this program, I have a library, ESP8266 Wi-Fi library, which is going to connect node MCU to my Wi-Fi router, and a PubSub client library, which is going to connect a client to this server, Raspberry Pi. Here I will have to change my IP address because my Raspberry Pi's IP address is 106. Okay, so I'm connecting it to 106, and then I'm uploading this program on my Node MCU. So this program is going to act as a client program. It is going to connect Node MCU as a publisher to Raspberry Pi server. Raspberry Pi already has Mosquito server or Mosquito broker running on it. Let this program be uploaded, and then I'll show you all this data which are going to be collected on Raspberry Pi. Okay. Okay, so I'm uploading new program, and now I think before I take you to next step where I'm going to connect my Raspberry Pi to AWS cloud platform, I think since this is already 1.5 hour, we have another 2.5 hour to go. Okay, so I think this is the best time where we can have a 15-minute break. So post this uploading, let me, once I show you data getting collected by Mosquito broker on Raspberry Pi. So now I have this uploaded. Let me take you to, okay, first thing, I'm going to show you this messages here. Okay, so the temperature value, it is being sent. Let me go to my Raspberry Pi, And there this time we are going to create a subscriber. Let me close all other windows because Mosquito Broker is running as a process. I'm going to create a local subscriber to subscribe to temperature topic. Okay, and we should have our data reaching to this subscriber. Okay, do you see this? The data which are being captured by Node MCU. Now Node MCU is connected to Raspberry Pi is a subscriber. So same data value, the data value which are being captured by Node MCU are reaching to the subscriber which is running on Raspberry Pi. Now see, on Raspberry Pi we can run multiple subscriber applications. I'm going to run another subscriber application which is going to upload data on AWS Cloud Platform. But before that, we'll have to create a virtual instance or a twin of our Raspberry Pi on AWS Cloud Platform. So how to register a device on AWS Cloud Platform, how to have your certificate and keys generated, how to have those certificate and keys downloaded, and how to use those certificate and keys is identity of your device as your device ID on your Raspberry Pi. This is exactly what we are going to experience. See, this is a time when we are entering into, since we are connecting our device to internet. And as we all know, internet is a public network, a jungle, So there are more and more possibilities of your devices getting exploited, your data getting intercepted, or becoming accessible to unauthorized entities, unauthorized users, or unauthorized systems. So this is exactly where the confidentiality, integrity, and availability of your data as well as your applications, and this could even be extended to your assets, cyber as well as physical. And this is exactly why I've decided to give you an overview of IoT security. And as a reference book, I would recommend you to read book authored by Brian Russell and Drew Van Duren, Practical Internet of Things Security. See, when it comes to security, most of times people either get confused or they take security for safety. But these two are different terms, and this is exactly what we need to understand. So when it comes to safety, safety means the system must not harm the world. And as we all know, IoT devices nowadays are controlling physical environments, real life environments. On factory floors, production systems are controlled by IoT devices. On highways and roads, cars are being controlled by, or other vehicles are being controlled by IoT devices. Inside your homes, take an example of an electronic lock placed on a home user's door, or a car which can be controlled, or locked or unlocked using a mobile app. These are all examples where IoT as a technology is interacting with your physical world. So the safety here, it's not just security that need to be taken into consideration. The safety also need to be taken into consideration. You need to ensure that system built by you, system designed by you, system architected by you are not harming its users. Harm could be in the form of loss of information or data owned by end user, or it could be in the form of, a physical harm. Okay, for example, a robot performing surgery, a pacemaker implanted, or a smart pacemaker implanted in a patient's body. Just imagine what could happen if these devices are hacked. When it comes to security, it's just the opposite concept. In security, we ensure that world means hackers. There are two types of hackers, white hat and black hat. Hackers or adversaries do not harm your systems. So you need to incorporate all those measures, you need to incorporate all those uh, security solutions, features into your systems so that those incidences could be prevented or could be avoided. Now, see, when it comes to IoT, as I alluded in the beginning of today's workshop, is not a simple system. It's an ensemble of multiple systems. It's a system of subsystems. Just securing one of the component of your IoT solution is not going to solve the purpose. You will have to adopt a holistic approach. You will have to address security at each and every layer. You will have to secure your device, you will have to secure your gateways, you will have to secure your communication channels, your local network, as well as the communication taking place between your local network and the cloud platform over the internet. Okay, so this is the reason why we need to dive deeper into these areas. See, when it comes to terminologies, I'm not getting into these details. Device things, most of them we use these terminologies in terms interchangeably. But what I'm going to share with you are these pillars of classic pillars of information assurance. See, today, since it's a beginner's workshop, so I'm just going to give you an idea of information security. But IoT security is not just confined to information security. See, there are three different areas where security has been need to be addressed, and these three different areas are three different technical areas, you can say. So there is cyber security, which also encompasses information security, because information or data is one of the cyber asset. Then there is computer security, and there is network security. So all this, when it comes to IoT, all this IoT security is a cross-cutting layer. IoT security encompasses all these domains. So we'll just focus on information security. And when it comes to information security assurance, these are the pillars of information assurance. Confidentiality means keeping the sensitive information secret and protected from disclosure. Integrity means ensuring that information is not modified externally or purposefully without being detected. Authentication means ensuring that the source of data is from a known identity or endpoint. Non-repudiation means ensuring that an individual or system cannot later deny having performed an action. And availability means ensuring that information is available when needed. Now, these three pillars, confidentiality, integrity, and availability, are also called CIA triads. We call them CIA triads. When it comes to confidentiality, you need to answer questions now, like what data requires privacy, what method algorithm is used, how will keys be managed, how is trust achieved. When it comes to integrity, you need to answer all these questions listed here, from how is data integrity preserved to how is the device and network trust achieved. And when it comes to availability, you need to guarantee availability of all types of assets. See, when you subscribe for a cloud service, cloud platforms, they guarantee 99.99% availability of resources, means your data, your application hosted on their platforms. So while building these systems, you as a system builder, as a system architect, or as a let's say application builder, you all will have to work as a team to guarantee security of all those assets, be it cyber assets or physical assets your systems are going to interact with. So let's say if you are building an electronic lock, the end user is going to rely on it, because the entire home is the security or and safety of home is solely going to be depending on your electronic locks security. What if someone hacks this lock? He or she can easily break into home, right? So this is why CA triad, these three parameters need to be addressed. Okay, I'm just skipping this, just to avoid getting into details. Let us look at application of CIA triads, and once again, I will skip this part, but let me introduce you to these four terminologies. The terminologies which you should be familiar with. The first term I want you to know about is threat. You know, a threat means the exploit potential, means someone who can exploit a weakness of your system. So a threat is like a window of a home or a building. If this window is open, a threat actor means a thief can break into building or home. Okay, so window, that presence of window is a weakness. Okay, similarly, presence of a weakness of in your system, for example, default username and password, or people can use this default username and password once they know IP address of your thing to use SSH, a utility like SSH or VNC, the way we use it today to connect to Raspberry Pi. This could be used to connect to your device, and then your device could be compromised. Okay, so a threat is like a weakness that could be exploited. So vulnerability means these weaknesses that could be exploited. Presence of insecure web interface is a vulnerability, right? The potential of that vulnerability getting exploited is threat, and the person or entity performing this action is called threat actor. The targeted exploit performed is called attack, and the compromise or impact of the successful exploration is called compromise. Okay, so always targets are assets controlled by IoT devices. For example, a car is an asset. One of the IoT device embedded in car may have a weakness that could be exploited by a threat actor to break into the car. Okay, so assets security could be compromised once a weakness or vulnerability exists in it. Now see, when it comes to dealing with these threats, there are different approaches. First thing, how are you going to detect the threat? Second thing, once a vulnerability has been identified, once the potential of this vulnerability getting exploited means threat has been identified, what kind of approach you would adopt? Either a deterrent approach or preventive approach or corrective approach. These are different types of approaches you can employ. Okay. Now see, when it comes to confidentiality, the first parameter that I shared with you, one of the approach that is employed is called cryptography. I don't know how many of you are familiar with this term, cryptography. See, cryptography is a science of keeping the secret, right? So I'm just getting you familiar before we go to AWS cloud platform. I just want to share this terminologies with you. I'm just going to share few examples with you. Okay. So cryptography, the simplest definition is the secret of keeping it secret. Okay. Cryptography is defined as art or science concerning the principles, means, and methods for rendering plain information unintelligible. Means even if someone reads it, the person should not be able to understand the information. And see, once it becomes unintelligible, there should be a reverse operation. Okay, there should be an operation to restore encrypted information to intelligible form. So this is called cryptography. Now see, cryptography, we use two terms, plain text and ciphertext. Plain text means the original message or usable information. And ciphertext means just opposite of plain text. Opposite of plain text means encrypted text, something that is not usable by, even if intercepted, even if acquired by unauthorized personnel. Okay, there are different primitives of cryptography: encryption and decryption processes. There are two types of encryption and decryption processes: symmetric and asymmetric. There is a one directional cryptography called hashing. There is a method called digital signature and MAC, message authentication code, and there is a method called random number generator. Now see, how do these primitives offer services to its users, and what kind of services do they offer? Encryption offers confidentiality, but it doesn't offer integrity, authentication, and non-repudiation. Hash offers integrity sometimes, but not always. MAC offers authentication, integrity, and non-repudiation sometimes. And digital signature, most of us use, offer integrity, authentication, and non-repudiation. Now see, none of these primitives are offering all those that is required to ensure security or confidentiality of integrity and availability of your assets. So this is why most of times we don't just use one primitive. What do we use? We use a combination of primitives. Okay. For example, if I go to a website, okay, look at this website, mosquito.org. Now, how do we ensure that this website is secure? It's an easy process. The presence of this lock and presence of S in the HTTP guarantees that this is a secure website. This is the server, which is actual server, the server which is owned by this organization called, organization whichever owns this website. Now, how to make sure how to get more details about it, you can go to this option and you can go for more information. See, it says verified by Let's Encrypt. More information. Here you have website information, who verified this, when is this certificate or verification going to end, expires on 12th May 2020, and what kind of algorithms are and methods are being used for security. So what do you see here? TLS stands for transport layer security. Elliptic curve Diffie-Hellman, it's a method used for key exchange. RSA is an approved NSA approved algorithm for asymmetric encryption. AES, 256-bit AES, advanced encryption system. This is once again NSA, National Institute of Science and Security, National Security Agency, sorry, uh, approved algorithm. AES. GSM SHA. So SHA stands for hashing algorithm. So this are all the algorithms, and a combination of this algorithm called cipher suite is being used for security here. Okay, and the version of TLS is 1.2. So let me show you how does this work. Because internet communication, the guaranteeing security of communication is a complex endeavor. It's not an easy task. Okay, let me just share one of the example with you. I have a code here. Okay, I'm going to use this code to show you how does encryption and decryption work. Okay, see, I have code here, and this code is going to generate a key. It's a Python code. Now, those who are new to Python, I'm just going to give them a basic idea about Python. See, in Python, we can use libraries. So I'm using a library called Fernet. Fernet is an open source library. We can use this library to generate keys. Okay, and what are these keys? Keys are used for encryption and decryption. How? Let me explain this with the help of a diagram. So there are two types of encryptions and there are two types of keys. The keys are called private keys and public keys. Private keys are kept secret by its owner, and public key is always available to public. And there are two types of encryption decryption processes called, we call them symmetric and asymmetric encryption decryption. Now see, when it comes to symmetric key encryption, two systems or two users, they use same key and same algorithm. Okay, a user, for example Bob, uses a key and an algorithm to convert plain text into a ciphertext. Ciphertext means something that is scrambled, something that no one can understand, even if captured. Now this ciphertext can only be converted into plain text by a user or an application which has the key which was used to convert it into ciphertext. Okay, so because both the parties, they use same key, this type of encryption is called symmetric encryption. Okay, I hope diagram makes it simpler to understand. Bob and Alice both are using same keys. Now let me show you how. How does it work? See, I'm generating a key here, and let me run this code. This line is going to generate the key. Okay, I'm using a method called generate underscore key from Fernet library. I'm going to print this key, then I'm going to use store this key in a file to be used by an algorithm. Okay, so I'm running this code. Okay, now see, this is the key. Okay, it's an alphanumeric string. Okay, it's a key, and this key should be kept secret. It should be known only and only to parties who are communicating with each other, because whoever owns this key, whoever has this key, is going to gain access to encrypted data. Okay, see, we store data on computers in encrypted format. Why? To keep it secure. We communicate data in a secure manner, right? To ensure confidentiality, right? So these keys, they play important role, right? So now I have this key saved in a file called sim1.key, okay, where on my desktop. Okay, now, what I'm going to do, I'm going to use this key in a program. Okay, so I have a program here. Okay, there's the one. Now, see, what am I going to do in this program? Once again, I'm using same library for net. I'm using my message or data is hello everyone. Okay, this is my message. I'm converting this data into byte data. Okay, using encode method. Just for your information, I'll print this data on my screen. I'll also print byte data on my screen. Okay, and then I'm going to use the key which was stored in this file sim1.key by another program, right? We generated key and we stored the key. I'm reading that key from there, okay, and then I'm printing this key, okay, the key which is going to be used for encrypt and decrypt, and closing the file. In the next step, I am passing this key to Fernet algorithm, and this Fernet algorithm is going to encrypt our data, our message, and we are going to I'm going to print this encrypted data for you. On the other side, I'm going to use the same per object created here using Fernet library to decrypt the data, and I'm going to print this decrypted data for you. Okay, so you will have all the components in front of you. Let me run this file. I'm running this module and see what do we have here. Okay, this should explain you the entire process which is involved here. And the example is AES. The example involves use of AES algorithm. AES means symmetric key algorithm. So this is our string data. Hello everyone. Converted into byte data. Hello everyone. Key to encrypt and decrypt is the same key that we generated here. Okay, that verifies same key, and this is transmitted data. Now see, this is what is being transmitted. Now see, this is completely different from our original message. Original message is hello everyone, and this is encrypted message. This is completely different from original message. Even if someone intercepts this, even if someone eavesdrop and capture this message is not going to be of any use as long as that person doesn't have the key. Okay, but look at the data is received and finally decrypted. We converted it back into original message, right? So this is how encryption decryption works, and this is an example of symmetric key encryption. Okay, see, in the next workshop on 8th of April, I'm going to share an example of end-to-end encryption decryption, means sending your data to AWS cloud platform and then receiving it back on a device and then decrypting it over there. Okay, today, since this is a beginner level workshop, I just wanted you to get familiar with this concept of cryptography. So MQTT, the protocol which is being used by us, MQTT also runs on top of this protocol or protocol stack called TCP/IP. And at transport layer, we use this protocol, security protocol called TLS, transport layer security. See, AWS cloud platform. The first thing, when you go to AWS cloud platform, AWS cloud platform, and as a matter of fact, not just AWS, all the leading cloud platforms, they do not entertain insecure communication. Okay, means this cloud platform, once you will have your device connected, is only going to entertain if the communication coming from your device is secure communication, encrypted communication. Okay, so HTTP communication not supported by AWS cloud, it should be HTTPS. MQTT communication is not supported by AWS cloud platform, it should be MQTTS, means secure MQTT. So these are the two protocols supported by AWS cloud, and which are those two protocols? HTTPS and secure MQTT. When it comes to Microsoft Azure supports MQTT, AMQP, and HTTP, three protocols. AMQP is also a message oriented protocol. Okay, so I'm just logging into my AWS account just to give you an understanding of what kind of services do we have here and how do we onboard our devices. Okay, so the service that we use on AWS cloud platform to register devices is called IoT Core. Okay, I'm taking you to AWS IoT console on AWS cloud platform. Okay, AWS IoT console offers you all sorts of tools to manage your devices, and the manage process obviously start with onboarding your device, right? So to onboard your device, you have something called a wizard. You can use a simple wizard to onboard your device, a single device, or even a fleet of device. Okay, so let's say you can have let's say a template created to have thousands of devices onboarded. Okay, if you're working on a large size IoT project. Now see, the onboarding a device process is very simple process. Where once you log into AWS Cloud Platform, what you can do, you can use this wizard from AWS IoT Console. Click on Get Started. It says you need to register your device before device could be onboarded. Now, what does this registration mean? See, registration creates a virtual copy of your device, your actual device. So let's say if I'm connecting my Raspberry Pi need to be registered here. Okay, uh, and this registration process also going to generate security credentials. So we just talked about security. It is going to generate security credentials, and then we can use the security credentials, which is which includes certificate and keys. I just gave you an idea what these keys are used for. Okay, so security credentials and this certificates we are going to use for our device identification. Now, whether you are using, let's say, a Linux system, and what kind of language you would like to use to develop your applications, you can select your environment, means OS, you can select your language. This is an optional step. Optional means it's not necessary to use SDK offered by AWS. What you can do, you can use your own language, your own SDK to develop your application. For example, we are going to use the library Paho MQTT. I just give you an idea how to install Paho MQTT on your Raspberry Pi, right? Now, look at this registration process. What are we going to get out of it? See, it asks for a name to be assigned to our device. So we can say, okay, Raspberry Pi device. Okay, I'm giving it the name Raspberry Pi device. Next step, once I click on next step, my device is going to be registered. Okay, so Raspberry Pi device has been registered, and I have a policy attached to this device. If I show you the privacy policy, this policy means all those operations which could be performed by my application running on Raspberry Pi actual device. So the actual device, once connected to AWS cloud platform, can perform this set of operations. What kind of operations? My Raspberry Pi and a Python application running on Raspberry Pi is allowed to publish, is allowed to receive only on these resources. It is allowed to subscribe only to these topics. That means this is a highly restrictive policy. Okay, policy are just like permissions assigned to your application. For example, when you log in into a computer using your username and password, the login process, verification of your username and password is called authentication. Once you're authenticated, then comes policies into picture. So let's say if you are logged in as an admin, you will have admin policy and permissions defined in that admin policy are going to be permissions associated with your profile. If you are logged in as a normal user, you will not have administrator's privileges, right? So these are all managed with the help of policies. So this is policy for our device. And here I have a certificate and a key, a private key. Okay, now what is private key? I will just explain to you. See, I can download this keys and certificates from here. I can have this keys and certificate downloaded and installed on our system. Okay, so I have this keys and certificate downloaded. Let me show you what is there in this zip file. Okay, so I'm unzipping this. This is connect device package. I'm going to unzip this to show you what is inside this. Okay, so let's unzip this in the downloads folder. I'm going to assign it a new name. I'm going to create a new folder, Raspberry Pi AWS. Okay, so I've created this folder, and now I'm going to take you inside the folder to show you what is there inside that folder. Okay, see, what do we have? We have a certificate, we have a private key, and we have a public key. Now, the example that I shared with you, there I only talked about one key, right? I only talked about one key that is used for symmetric encryption decryption process. Now, why there are two keys here? So let me explain this to you. See, there is a second method called asymmetric encryption. So whenever we use the term encryption, decryption automatically comes with it. Okay, reverse process called decryption. See, in the 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 problem with symmetric encryption is common keys. Okay, and once these keys are compromised, once these keys are open, you know, uh, I mean, say the security or both the users, both the parties who are engaged in communication is compromised. Second thing, there are, it's really difficult to have these keys shared, because keys could also be stolen, while you are sharing the keys could also be stolen. Okay, so, and third thing, this keys, use of common keys doesn't allow a new party to engage into communication. Now, let's say Bob and Alice, they both have this key, but except them, a third person or a third user cannot engage in communication with them. Okay, if this third person is not known to both of them and doesn't have this symmetric key available to him or her. So to overcome all these difficulties, this new technique was invented, and this method is called asymmetric key encryption. See, asymmetric key encryption involves two processes, or involves use of two keys. Okay, these keys are called public key and private keys. A public key is of a user is available in a public domain. Okay, so there are public key infrastructures, PKIs. You can easily find public key of a website, public key of, an organization openly available to you. You can go to cert.hsh website and you can easily find, just search for a domain name or a company name, and you will find their public key information. Okay, so public keys of organizations are known to everyone. Okay, but not private key. Okay, now how do these keys work when it comes to encryption? See, Bob, let's say Bob, a user, wants to send some information to Alice. Now, what Bob would do, Bob is gonna grab the public key of Alice, and Bob is going to use this public key to encrypt plain text. Okay. Now, once the plain text has been encrypted by a public key, it can only and only be decrypted by private key owned by the person whose public key was used for encryption. Okay, so that means since Bob is using Alice's public key, this information once encrypted can only be decrypted by Alice. That's wonderful, right? For example, if my Raspberry Pi encrypts data using public key of AWS cloud platform, this data can only be decrypted by AWS cloud platform. I hope this is clear to all of you. So my device, my Raspberry Pi, is going to use public key generated by AWS cloud. See, we have public key here. My device is going to use public key to encrypt data to send to AWS, and only AWS cloud can decrypt this data. But now question is, how are we going to ensure that this public key is public key of AWS cloud platform? Because people can easily, hackers can easily replace this public keys stored on public key infrastructures. So this is exactly where certificate comes into picture. See, a digital certificate is like a document issued by an authority. Okay, so this certificate issuers are called CAs, certificate authorities, and the certificates format, the most commonly used certificate format is X509. So an organization can have its public key certified by a CA, certificate authority. Okay, so what does organization do? Organization shares its public key with all the required documentation to a certificate authority. There are certificate authorities like Symantec. Symantec is a certificate authority, right? So Symantec, what does Symantec do? Symantec physically verifies that yes, this website or this particular server is owned by this organization, its address, phone number, everything, almost all the physical, after physical verification, CA issues, a certificate that yes, this public key is owned by this organization or this website. Okay, so as you can see here, we also have certificate available to us in this folder, right? This is certificate. So this certificate and this public key and certificate, both are used in a combination, because this public key is not going to be of any use if a certificate is not there. So certificate is used for public key verification. And then private key, I just showed it to you. Why do we use private key? See, along with this, we also use a certificate called root CA certificate. Okay, so we can either download root CA certificate. Root CA certificate means the authority which has generated, which has uh, you know generated this root CA certificates. So either you can download root CA certificate from AWS website itself, or you can download root CA certificate from organization like VeriSign or Symantec. Okay, so as you can see here, we have an Amazon root CA certificate. This is a root CA certificate, and root CA certificate, the content of this certificate is publicly open. As you can see here, I can look at Amazon's root CA certificate. Root CA certificate is used for verification of device certificate. Okay, so this is just a long story short. There are multiple layers of securities, and once all those layers of securities have been, I mean, say, crossed, that this ensures end-to-end security. So as I just alluded, TLS protocol, transport layer security protocol, or uses all this certificate and keys. Okay, we don't need to do all these things the way I showed it to you, that I was encrypting, I was generating my key, I was encrypting data, and then I was just decrypting data. This you can do at application layer. But TLS, transport layer security, which involves use of all these keys and certificates, automatically does this for you. You don't need to do anything. Let me show you this with the help of practical example. See, now I'm going to show you a practical example. Our data is being collected here, right? Our data is being collected by uh, Okay, let me show you this example first. Okay, so this is what I did here. This is my Raspberry Pi code, and this Raspberry Pi code, as you can see, let me walk you through this code. See, this code is based on PAHO MQTT library. Already shared information about PAHO MQTT library, a Python MQTT library, and there are other libraries which are being used here. JSON stands for JavaScript Object Notation. OS, which is a built-in library. Socket, which is a built-in library for communication. SSL, which is also built-in Python library, Secure Socket Layer, and SSL library is used for TLS implementation. Then time and random, these are just simple libraries. Okay, what I did here, I have created three functions. Wherever you find def keyword inside a Python code means you have a function. Okay, so which functions do we have here? The first function is on connect pub, and this function is going to be called automatically when our MQTT successfully establishes connection with AWS Cloud Broker. AWS Cloud Broker means AWS IoT platform. Okay, this function on connect is going to be automatically called when this Python application is going to establish connection with local broker. Local broker means the Mosquito broker running on Raspberry Pi. And this application is going to subscribe to this topic called temperature. Now, as I explained, our Node MCU microcontroller is already publishing on this topic, right? Let me show you. Our code is still running. Our Node MCU microcontroller is continuously publishing on temperature topic on MQTT broker, Raspberry Pi's MQTT broker. Now, once I will have this Python application subscribe to it, it will start receiving data coming from Node MCU. And on the other side, once this message is received, this on message method is going to, or on message function is going to send this data to AWS Cloud Platform. Okay, and this publish call, this publish call is going to publish this message. It's a JSON message. Now, what is there inside JSON message? See, inside JSON message, I have put a serial number of my device 001. I put a device ID 007. I put a location, my home, and actual temperature. Temperature is message.payload. Now, from where I'm getting this message.payload, I'm getting this message.payload from here, from this topic temperature. Okay, so the actual temperature, it is going to be published. Just for your information, I'm going to print message.topic and message.payload, and then I'm also going to print final message sent to cloud. Okay, published on temp topic. Now, how are we establishing connection with cloud? See, to establish connection with cloud, what do you see here? I have created two clients. One is a subscriber, which is going to connect to local Mosquito broker on Raspberry Pi. This second client, MQTT pub, is going to connect to AWS Cloud Platform. Okay, and here I have put my local Mosquito brokers information, and here I have put my AWS Cloud MQTT brokers information. Now look at the difference. The communication of this application with local broker is not secure, right? The communication between Node MCU, the sensor node we built, and Mosquito broker is not secure. So the local communication taking place within our network is not secure. But from Raspberry Pi to cloud, okay, as you can see here, from Raspberry Pi to cloud, the communication is secure. And to ensure this security, what are we using? We are using root CA certificate, we are using device certificate, and we are using private key. The device certificate already has public key. Okay, so we are using all those components that we downloaded from AWS post registration of our device, and this is why registration process is needed, because registration process generates all those keys and certificates which are used by your device to secure communication originating from your device and reaching to cloud platform. If this communication is not secured, cloud is going to say no. Cloud is going to deny to accept even a request to connect to it. Forget the data exchange. Okay, so now once all this is done, then I'm sending a connect request to my AWS host. And even this AWS host, this is also a unique host name. This always account specific host name. This is my host name, my account's host name. Let me show you where you can find this. So if I go to, so anyway, this process is completed. So let me click on done. Okay, let me click on done. So I've registered a device. Okay, and I can find more information about this. I click on done. Okay, I have all these devices registered here. Raspberry Pi device we just registered. I have a device, my device 3108. Okay, so I'm using this one right now instead of Raspberry Pi device, because downloading and then transferring the certificates to Raspberry Pi itself is going to take some time. So to speed up the process, I'm using this already created device certificates, my device 3108. And all of my devices, all the devices that I own are going to use this as host name, right? So this is the host name I'm using in my code, the Python code that I have put on my Raspberry Pi. See, this is host name. 888 look at the reference. Here, local mosquito broker, the subscriber client connecting to local mosquito broker is using port number 1883. Whereas this mosquito client connecting to AWS Cloud Broker is using port number 8883. So this is, these are the ports used by MQTT protocol. 1883 is used by standard MQTT communication, and 8883 is used by secure MQTT communication. Okay, so now I'm going to run this application for you. And as you can see, this TLS set, we are passing path, CA path, root CA certificates path stored on in a folder on my Raspberry Pi. I passed certificate keys path. I passed private key path, right? And here I have specified the TLS protocol version to be used. And TLS protocol version, as you can see here, is 1.2. So I'm using TLS version 1.2. So same protocol which is used by websites for that converting HTTP into HTTPS, right? So same TLS is being used here to convert normal MQTT into secure MQTT communication. Okay, I'm going to run this code now, and the moment I run this code, okay, I should get a message. Okay, see, it says connected to Edge Raspberry Pi. Edge Raspberry Pi means my local Raspberry Pi, which is collecting data from Node MCU. And then on the other side, I'm connected to AWS Cloud Broker service. A zero MQTT broker always returns a zero in case of successful connection acceptance. Okay, you will get zero only when your connection is successfully accepted. Now see, this is topic temperature on which my Python application is getting data from Node MCU. The data values 31.21, 31.52. These are temperature values being published by my Node MCU, and these are the JSON messages published by my Raspberry Pi on cloud. Okay. Now, question is, how are we going to verify that this data is actually reaching to cloud platform or not? Okay, simple. See, on cloud, we have a dummy client. Okay, so if I go to cloud, AWS IoT console, on AWS IoT console, first thing, it offers you all this statistics of your devices, that how many devices are connected and what kind of messages are being exchanged. Now, if you want to look at those messages, what we can do, we can use a dummy MQTT client on AWS cloud platform. Okay, what I can do, I can subscribe to a topic called temp. Okay, I can subscribe to topic called temp. Now, why am I subscribing topic temp? Because my Raspberry Pi, is publishing on this topic temp. So look at this. On this cloud, where is publish call? The call to publish. Okay, it's here, right? See, my Raspberry Pi, this client is publishing on temp topic. Okay, so this is why on AWS Cloud Platform, I'm subscribing to temp topic, and look at this. I'm getting messages. Okay, but why not JSON? Why just temperature? Oh, here I'm just publishing message.payload. Okay, so let's do one thing. I will rerun this because data to cloud. This is what I need to publish, right? JSON, the final JSON message. So I'm rerunning the code. Okay, so I was printing something else, publishing something else, but now we should start getting JSON messages. Okay, good. So we have successfully connected our device to AWS Cloud, the world's best cloud platform. And on this cloud, you can build a larger solution. Means you can have your data uh, forwarded to other services at the back end. You can use cloud storage, you can use cloud database, you can use cloud visualization services, you can use machine learning AI services. You can have this data integrated with user applications running on mobile phone devices, or even on your uh, enterprise solutions. Okay, now see, we cover all this in our regular training programs. The training programs that we offer, we cover all this in detail. You know, how to have your devices designed, how to have your devices built, not just AWS, but also with Azure cloud platform. So Azure from Microsoft is also a leading cloud platform, and there too you can have your data uploaded, and you can build your IoT part of your cloud part of your IoT solution. That's it. What do we do? Whichever component being used by me over here for this demonstration, we supply all these components to those who are joining our IoT training program. Okay, so whatever hands-on experiments I'm performing here, this is just one of those hands-on exercises. You know, there are almost 25 to 30 other exercises that are covered in our IoT training program. So those who are interested in joining our IoT training program, this is the best time to utilize uh, for learning. So those who would like to upskill, or those who would like to reskill themselves, they can contact our team, or they can directly drop an email or a message on our website cognitia.com. Okay, so now once we have data on our cloud, what are we going to do next? The next thing is we should have a data at the an application at the other end receiving these messages, right? So that the message can complete a round trip. Okay, so I have another application here. I can run this application on this Raspberry Pi, or I can have this application transferred to second Raspberry Pi. Okay, so this is the application that I'm going to run here first, and then I'm going to run this application on the Raspberry Pi that we configured. Okay, the application's name is, let me find it first. Okay, so this is the application, and this application is again based on Python, same Python library, but this application is going to do something else. What is it going to do? It is going to connect to cloud, and then it's gonna receive messages published by NodeMCU on Raspberry Pi, and then Raspberry Pi on cloud. Now, just to give you an idea that you can run this application on another Raspberry Pi, what I'm going to do, see, currently I'm on this Raspberry Pi, which one? 106, right? And you can see this from here. I'm on 106, and there is we configured the Raspberry Pi, which has IP address 104. So what I'm going to do, I'm going to show you how to transfer files from one Raspberry Pi to other Raspberry Pi, or from Raspberry Pi to a laptop. And for this, you can use this application called Bitwise. Okay, Bitwise SSH client. Okay, see right now, the first thing is I will have to connect this Bitwise client to this Raspberry Pi. Okay, 192.168.0.106 on port number 22. It is going to use SSH protocol to connect. Okay, see it says accept and save. Asking for password, I'm going to put password Raspberry. Okay, so now see, I'm connected to, on one side, I have my laptop's desktop. Okay, and on this side, I have a Pi folder of my Raspberry Pi. Now what can I do? I can drag and drop files from here. So the file I want to copy from here is, let me check, iot underscore sub.py. Okay, so I'm going to copy this file. Those who are technology enthusiasts, IoT has a lot to offer to you. Lots of interesting things. Okay, where is IoT sub? Okay, this is the application. I'll just drag and drop it here, like on my laptop's desktop. Okay, and let me check. I already have AWS 3108 folder on my laptop desktop. Now what I'm going to do, I'm going to drop this connection and I'm going to connect to second Raspberry Pi. Second Raspberry Pi means 104. Okay, so I'll say, okay, close this connection, close this connection. Okay, now I'm going to connect to 104. Okay, I'll say logout and log in to 104. It's asking for password. Password is same, Raspberry. Okay, so now we are connected to second Raspberry Pi and I can easily drag and drop these files and folders from here. So AWS 3108, which has all those certificate and keys, I dragged and dropped it here. And then what else do we have? We have IoT underscore sub, the file here. Okay, I'll drag and drop this file here. Okay, those who are interested in joining next workshop on it, I'll share these programs, these programs involving cryptography. Okay, so now see, I have transferred this files. I can close this. Now let me go and check whether these files are there or not. And good thing is the files are there. Okay, we have iot underscore sub .py here, and I have this folder AWS 3108. So I'm using same set of keys and certificate on both the Raspberry Pi. This is not a good practice, but just for demo purpose, I'm doing this. Otherwise, you should, in a real implementation, you should register your devices separately. So I have two Raspberry Pi. The second one is hidden. Okay, let me show it to you over here on my webcam. I'm creating some space for it. Okay, and I'm going to show you where is this second Raspberry Pi, the one which was being used by us, and the one that has. So I'm sharing my webcam with all of you, and now you see this is my second Raspberry Pi. Okay, let me show you. It was hidden. Okay, so now we have complete system. Node MCU publishing on this Raspberry Pi. Okay, this is my broker, and this Raspberry Pi is publishing data on cloud, which are being received, which are going to be received by this Raspberry Pi. This is the one that we set up. Okay, new Raspberry Pi. Okay, so I have two Raspberry Pis, one acting as publisher, second one is connected as a subscriber. And now let me run this application, the one that I copied. I'll run this application, and I'm going to run this application in a terminal window. Okay, I'm not going to use any editor here. I'm going to use this in a terminal window. So IoT sub.py. Okay, no module paho mqtt that client. Didn't we install? Okay. Oh, see here it's using Python 2, and what I need to do, I will have to reinstall MQTT library for Python 2. Okay, Python 2.x, because my application is based on Python 2.x, so it wouldn't take more than a minute typo. Okay, so this time I'm not using pip3, I'm using pip. Okay, so I'm installing Paho MQTT for Python 2.x. Paho library supports both the versions of Python, version uh, 2.x as well as 3.x. So let me rerun that code, IoT underscore sub dot py. Okay, it says connection return to 0 and good. See, the data being published by 106, the Raspberry Pi, which has, you can check this on my webcam, as well as I'm also going to show you both the Raspberries. Okay, this is 104, and let me show you 106. 106 is sending data to cloud, okay, which are being received by, okay, these are data which are being received by, say 106 is sending and 104 is receiving. Okay, so data has completed round trip, and this data is being captured and uploaded on local Raspberry Pi by Node MCU. So the architectural diagram that I shared with you at the beginning of session, the architectural diagram, this is exactly what we built here, right? This is exactly what we built here. We have an IoT node based on Node MCU and an LM35 temperature sensor. It is connected to Raspberry Pi, which is acting as a gateway. Okay, then we have second, like we have connected this Raspberry Pi to internet, communication taking place over internet, data is going to cloud, and from there data is going back to this Raspberry Pi, okay, second Raspberry Pi. And now I have all the data available there. But see, my data is also visible on cloud, right? My data is clearly in text format. So what if I don't want even the cloud platform to look at my data? What if I want to hide data even for AWS cloud platform? In that case, what can we use? We can use end-to-end encryption, and MQTT does allow you to deploy end-to-end encryption. This is what I'm going to cover in the next workshop. So what did we learn from here? What is the takeaway from this entire demo? See, this is just one of the part of IoT learning. This is not whole learning, right? This is not uh, end-to-end learning. This is just one of the part. Building a technology infrastructure. Okay, I did not talk about data. I did not talk about data analytics. I did not talk about data strategy. I did cover all of these topics in one of my webinar. And those who attended that webinar, I believe a couple of you would have attended that webinar. I did talk about data analytics, how to deal with data coming from IoT devices, and the role of a language, this language called Python, and advanced Python libraries. So I covered this in my IoT training program. I have trained more than 3,000 IoT professionals in last 3.5 years, and I have trained more than 8,000 engineering graduates. So you can find this out from my profile on LinkedIn. You can send a request and connect with me on LinkedIn, and can stay in touch with me over there. As I said, when it comes to adoption of IoT, an organization need a well-crafted strategy, and this strategy has multiple components. One of the component is technology strategy. The second component is data strategy, and there are a couple of others. Now, what did we talk about today is one of the part of technology strategy. How to select your technology components. So how to select a IoT device platform. Now, which platform did we use today? Node MCU. Secondly, we used this second gateway. As a gateway platform, we use Raspberry Pi, and the cloud platform we use AWS. See, the selection of this technology component is highly strategic. You will need to take all these key parameters into consideration the considerations like reliability, resiliency, interoperability, and security. Okay, so and privacy too. Okay, so anyway, the discussion on a detailed discussion, deep dive on these topics is out of scope of today's workshop. I will have more coverage of these topics, and I will have more exercises, covered in the next workshop. But before that, let me communicate with support team. I need to check whether an online assessment need to be organized for you guys or not. Just hold on, please. Let me call support team and communicate with them directly. Assessment, end of the workshop assessment, was is a part of this workshop. But for that, you will get a link directly into your inbox. You can take part in that assessment to get a certificate from Cognixia that you attended a practical workshop and you have gained the knowledge of system building, end-to-end system building. The team from our end, your support team will be in touch with you. You can drop an email to them proactively, or they will drop an email to you. They will share a link to attend this online assessment. The assessment is going to be based on MCQs, multiple choice questions. The questions are going to be based on topic that we discuss in today's workshop. In case if you have any queries or questions, you can also drop those queries and questions and can share this with me. If you would like to, I can take questions from I can spend, let's say, 5 to 10 minutes of time in case if you have any question, because there are 500 plus participants here. So I don't think I would be able to take questions from all, but I can take questions from a couple of you. So let's say 2 to 3 participants. You can use hand raise option uh, available in your tool to share your questions or feedback if you would like to share, so that I can prepare, all those with all those input for the advanced level workshop if you are interested in attending that. So Prerna, I'm handing over the session to you. I have completed demonstration of end-to-end solution.
Great, Shafi. Thank you so much. I'm sure this is going to be very well productive and informative for the attendees further on, and this should be able to generate more interest into them. So, thank you so much again for conducting such a
You're most
information.
welcome.
All right. So, thank you, attendees. I'm glad to see that majority of you are still here, and that definitely proves that this was a successful session. We would be conducting more sessions further on. A quick note for you guys, because this was a workshop and not just a webinar, we can help you with assessments and certifications if you are interested for that. We have kept this process very simple. My support team will be reaching out to you in the simplest possible manner, which would be through emails. They'll share an email with you in case you are interested to have yourself assessed and certified for this particular workshop. You can write back and they will help you with the further steps. Uh, just to add, there will be a very normal cost attached to it, which will be shared with you over email as well. In case that is all feasible for you, please write back and we'll be happy to assist you there. All right. I think with that, it's a wrap. In case you're looking forward to an even more extensive, detailed training session on this, please write back to us again and we will be able to help you out there. Alternately, all my corporate attendees can reach out to their training teams or the learning and development departments, because we are partners for your organization for all the learning sessions that happen, and we can have this conducted through them as well. Okay, thank you so much, everybody. Please stay safe, stay indoors, and take care. Bye bye.